All right, so with this one, CH4, right? So the first hard part with this one is figuring out how many atoms am I working with here, right? So if I look over here, C, one C, and then since there's a 4 right next to the H, right, subscript, I know that I have 4 hydrogens to deal with. So I've got 5 total atoms I'm going to be working with. The hardest part about this one is making sure that everything is organized so everything is placed where they go, right? And then I'm going to be moving things around so that way I can fit this better and so on. But just to start, I'm going to have it like linear like this. So I'm going to look over here. I'm going to look here. Carbon is right there. So I know that 8, 7, 6, 5, 4. Carbon has 4 valence electrons. And hopefully at this point, you know that hydrogen has 1 valence electron. So let's put all that stuff together. All right. Like I said, I think this is much easier than ionic bonding, just because usually there's a lot less that you have to deal with in regards to valence or this kind of stuff, and I don't have to deal with brackets and stuff, right? Oh, sorry, I'm gonna put these here so that way you can see them better, right? Okay. So now what you have to look at is, as I mentioned before, the hardest part with this one is figuring out, right, which ones should bond with which ones, right? Um, so the rule of thumb is you always look for the atom that has the most amount of unpaired electrons, right? Since hydrogen only has 1 electron, it's only got 1 pair. It doesn't have any pairs, but it only has 1 unpaired electron. If you notice, carbon has 4 separate ones. Now, this is the reason why I don't like you guys doing this, right? Because then you're going to be like, well, carbon is all paired. Well, in reality, no, it doesn't. If I do this right and I draw this out, I should have 4 unpaired electrons, right? So if I have this, I know that carbon has the most amount of unpaired electrons because every single valence electron is unpaired. So this makes it really, really simple now because all I have to do is I move this one over here, right? And I'm going to move these things a little bit over so that my screen can kind of see this, right? So I'm going to move this around. Then I'm going to move this hydrogen over to this one, move this hydrogen across from this one, and I'm going to move this hydrogen across. So everything surrounds the one with the most or the least or the most amount of unpaired electrons, which is carbon, which has 4 different ones. So from here, now that I have everything across from each other, all I have to do is put rubber bands around each one, and I'm done, right? So if I look at it, if I count the carbon, I now have 8 valence electrons around it, right? So I have the 4 green ones it started with, but now that I bonded, it's got the 4 red ones too. So now that's 8 total valence electrons, right? And hydrogen has 2. 1, 2, 1, 2, 1, 2, 1, 2. Remember, hydrogen is in the first period, right? It's in the first row. So that means it's only, right? First electron ring is always full with 2 valence electrons, which means that hydrogen only needs 2, right? So there you go. This is what CH4 would look like, all right? Remember, we don't have to use brackets because electrons are not being transferred; they're just being shared. Okay, all right. There are 2 more toughies, all right. So give them a go, have at it. They're not required, but if you want a challenge, go for those ones. Okay.